Good morning, everyone. Today is our lecture number 19 in the organic chemistry. We are in the 10th chapter, chemistry of life. We will learn carbohydrates, food and nutrition first, carbohydrates, amino acids, proteins. Today, we will learn about fats, lipids, and fats. Okay? And we will learn the chemical aspects. I will explain to you its chemical aspects, and I might not be able to explain to you the biological aspects. I don't need to, but I will also share with you some of them. Okay? So there we go. Okay? Lipids. What are lipids? What are lipids and fats? What are they chemically and what are they generally? So, my dear students, when chemistry was still developing, it was not a developed science. Scientists didn't know exactly the internal structure, the bonding, atoms, electrons were not discovered. There was, it took time for science to develop, it took centuries. And that's the beauty of science. It takes time. So the scientists in the early times, they used different methods to define a class of compound, like carbohydrates, hydrates of carbon. Later on, they realized it was wrong. So the different ways, the olden ways, how to define a compound or a class of compound. For lipids, there's also an interesting way. Okay, so they define that those organic compounds which are soluble in Bleu's region are known as lipids. Now, what is Bleu's region? Because fats and lipids were very strong and they could not dissolve in any single organic compound. So Bleu's he used two strong organic solvents, strongest, diethyl ether and ethyl alcohol. Okay, this is a very strong combination of any solvent. So a Blue's reagent was a combination of diethyl ether and alongside that ethyl alcohol in some ratio, 2 ratio 1, which means that 2 moles of ether and 1 mole of ethyl alcohol. All right. So this by then it was defined that only those compounds are called fats or lipids which are soluble in this strong solvent couple, 2 volumes of diethyl ether and 1 volume of ethyl alcohol. Okay, but what were they? They contain carbon, they contain hydrogen, they contain oxygen, just like many other organic compounds. So what are they? Carboxylic acids? Are they carboxylic acids? Are they ethers? Are they polyhydroxyaldehyde? What are they? It took time for science to discover all that. So until the discoveries took place, scientists defined them, classified them in their own fancy ways. This is a fancy way. It's not scientific, but it's a fancy way. So there was a classification into 3 different types: simple lipids, compound lipids, and steroids. If you remember, simple proteins, just the proteins, right? Conjugated proteins, the combination of 2, and then you have a complex. In the same way, you have the simple lipids or compound lipids or steroids. So let's go toward the simple lipids. Now, simple lipids are basically all the oils and fats and waxes They're called simple lipids. So if you have cooking oil in your house, dalda oil or any ghee, or if you have makhan, you know, if you have butter, they are all simple lipids. Okay. So naturally occurring oils, naturally occurring fats, naturally occurring waxes, they all called simple lipids. And chemically, they are esters. Do you know esters? From the ninth chapter, when carboxylic acids react with alcohols, it forms esters, ethyl acetate. If you remember, now ethyl acetate is not a lipid. Then why all esters are lipids? No, those esters with their very, very long chains of fatty acids. Okay, and they bond with alcohols with longer, like glycols minimum, sorry, glycerols, you know, try 1 comma 2 comma 3 propane triol, minimum 3, just like in the carbohydrate, you know. So now you can understand why carbohydrate can easily convert into fats, because the hydroxy group has some kind of affection with the carboxylic group, and they make H2O, and then they bond to make ester. So if you have one carboxylic group, OH, you make one ester. It's called monoester. If there are two OH, diester. If there are three OH groups, it's called triester. So basically, fats and lipids are triesters. Esters, amino acids are amines and carboxylic acids, right? Fats and lipids are esters, chemical. Okay, so here we go. Naturally occurring fats and oils are esters of glycerol. Glycerol is minimum 3 OH groups. More is okay. And carboxylic acid with at least 12 to 20. Not the ethyl acetate. No. Not the ethyl acetate or propyl. You need a carboxylic acid of a really long carboxylic group. Minimum 12. The stearic acid, the hexadecanoic, the palmitic acid, like those. And then in them there are double bond and single bond, like saturated, unsaturated. There is a further classified chemical. So now you know chemically what are fats and lipids. By chemical point of view, fats and lipids are triesters, or they are triglycerides, triglycerols. Now, if you do, if the doctor tells you that you should check the fats in your blood, I go through the fat tests every 6 months in a year, and the first thing he wants to see is triglyceride level in my blood. So, what is triglyceride? Triglyceride is triglycerol, glycerol with fatty acids, the fats. So look at this, please. Everyone focus. What is this compound? It's glycerine, glycerol. You know, if you are using a lot of hand sanitizer, and if it is gel-like looking, it's because of this guy, glycerol. Are you pick name? 1, 2, 3. What is it? Propane, triol. And these are carboxylic acids. These are simple ones. The R should be at least 11 because 12 is this one. So when 3 carboxylic bond with the glycerol, sorry, this orange square is wrong. The H from here and the OH from here. If I can make another one, the OH from the alcohol and the H from the carboxylic acid. There's one H2O, and there here we go, the other H2O, and there we go, the other H2O. 3 OH. And this carboxylic group, this O bonds to the CH2, this O and this O. So three long carboxylic acid chain bonding through the glass roll, and you get a solid. A solid or oil, lipids or oils or fats both, depend upon the length of the chain. The bigger the molecular size, then it will be a solid. The less the molecular size, it might be a very thick oil, or both. Also depend upon temperature. So, my dear friends, if you can see that, now you know chemically what are they. Okay, now you understand. So there's no difference between oils and fats. There's no difference between them. Compounds which are solid at room temperature are fats. Triesters, minimum triesters, which are solid at room temperature are fats, and triester which are liquid at room temperature are called oils. Both fats and oils are same thing. If your doctor tells you don't eat fat, like don't eat ghee and use oil, that's old thing. Because chemically they are same. Just because ghee looks solid and oil looks liquid, and oil will not kill you and the ghee will kill you, is totally wrong. Because chemically they are both triesters. So no, it won't kill you. Okay? So this is the whole thing. So butter is great. Don't miss out on that. So both fats and oils, they belong to the class of esters, known as glycerides, triglycerides. Glycerides, why? Because glycerols. Esters of glycerol, glyceride. Known three, so triglycerides. Liquid at room temperature, oil, solid, it will be called fat. So the oils, they contain mostly enes, double bond. The carboxylic acid is like having a double bond in between. And they both have fats and oils and fat both have double bond, single bond. But the oils have more double bond and fats have more single bond. Now, as a chemistry teacher, I will shock you today. Fats are better than oils. Ghee is better than cooking oil. Why? Because the double bonds, once you cook them, they polymerize. Polymer are more dangerous than. So if the fat, it is a long debate. I don't want to go into a new chapter here. Okay? They say fats are bad because fats are saturated. Well, if they are saturated, they don't have pi bond, they don't make polymers inside your blood. Okay? But oils have more pi bonds and they make polymers in your blood. That's why we say the old people used to use ghee and sacho ghee and butter or whatever, and they were fine because it's good for health. So let's go. Now the oleic acid and linoleic acid, they all have pi bonds. There are more of them. Like both oils and fats have all of them. But fats have more palmitic stearic, which are saturated, the octadecanoic, and the oils have more oleic, the octadecanoic. This is the difference. Chemically, they have both, but the oils have more alkenes, double bonds, chain in one more double bonds, and fats have more single bond. If you ask me, I'm a doctor, but as a chemist, I'll tell you the saturated fat acid are better for you because they don't polymerize once they go into your body. If you still want to confirm a test, simple fry, use your frying pan and get some French fries. Once you fry the French fries and you leave that oil for a while, a thick, strong layer is made on top of it. It polymerizes. Pi bonds polymerize. So this is the difference chemically, and some of the difference I told you about medically. I don't know much about it, but I'll try it. So some oils are drying oils, some are non-drying oils. Now, what are drying oils? Drying oils are those which contain large number of double bonds, triple bond, triglyceride of unsaturated fatty acids, linoleic and lanolinic. I'm not sure, but they both are octadecanoic or decanoic acids. They're called drying oils because when they're exposed to air and heating, upon oxidation, double bonds open up, polymerization, and on the top of this, dry, hard film is formed. This oil is bad. That's why they say that once you fry something in an oil, you have to discard that oil and don't use it over and over again. And when you eat pakoras and samosa from outside, I mean bazaar, they use the same oil all through the day. So you get really sick if you do that. You don't get sick if you eat once in a while because your system can cope up with that. But if you eat it a lot, heart attack. Oils give you heart attack. Ghee doesn't give you heart attack. Why? Because they are non-drying. They, they have very little bit of pi bond. This is chemistry, okay? If you know polymerization, then you should know that the oils look very oily, but it's not very healthy. And ghee looks very ghee, but when it goes inside your body, it doesn't polymerize that much well. Then why is the ghee monster? Why for a long time people avoid having ghee? What happened to ghee? The answer is that the ghee looks like solid, and people at the olden times will just look around the outer structure and decide and not see the inner chemistry. So this is drying oil and non-drying oil. Small differentiation can they be there? This is the answer. Why some oils are drying and why some are non-drying? Those with very negligible amount of pi bonds, okay, unsaturated. So rancidification is also a small definition. If you leave the oil and fat in open moisture, what happens? At time they become bad. They smell bad and they taste bad. This is called rancidification. Why it happens? Because of the hydrolysis. Okay, the pi bond they break and they make aldehydes or whichever very bad smell. This is the chemical reason why fats smell bad when they're exposed to moist air. You all know that this is a chemical reaction. Waxes are also, but they're fats, they're also esters, but they're very long chains. Their chains are really, really long. Okay? Long chain alcohols, not glycerol, triols, but pentaols, hexaols, longer chains. Okay? They have a wax-like feeling. The wax which you use at home, which I once joked with you about Vaseline. Okay, in our houses we call Vaseline is a company. Wax is the name of that substance which you use to moisture your hands. So why does it feel like lipid and fat? Because it contains many alcohols bonded with many fatty acids. So any chemical substance with this two will definitely be an oil or fat. So waxes are also in the same chemical category. Some are true wax and some are non-true wax. True waxes are simple lipids and non-true are basically complex ones. Okay, vitamins are also like that. Cholesterol is a non-true wax. You can call oils a wax. Oils, lipids, fats, same thing. So you can see bee wax and you can see spermatic wax. Now what is beeswax? I'll explain to you. beeswax, my dear friend, the honeybee, if you know it, okay? If you know honeybee, have you ever purchased honey from some person? Honey is inside the wax, and if you have purchased honey on a tree, the honeybees they produce a wax from their bodies to make a coating, and inside those wax they hide the honey. They don't make honey for us. We shouldn't try that honey. That honey is made for the children of the queen bee. Anyways, like that. The next one is spermatic wax. Spermatic wax, what is that? It is present in sperm whale. Whales have wax. The fish fats. These are others. Okay. Also, they are present in. Okay. So this is it. And now we see what is compound lipids. Now compound lipids are basically a mixture. Okay. They are also esters of glycerol with two saturated, okay, or two unsaturated fatty acids, okay. But they also contain carbohydrate like conjugate proteins. Yeah, this is called prosthetic group. A protein may combine with them. If you know VLDL, LDL, lipoproteins, combination of lipid and protein, and also glycolipids. Like these are the compound ones. Okay, there are different types of it. And steroids are the third category of the fats and lipids. They don't make fat. They don't make soap. If you put any fat or oil in NaOH, it will make soap. Soap is also made from them. You know, soap, Lux soap, they are fats. But steroids don't make it because they are cyclic. Many cycles, ring structures. Fats and lipids, straight chains. Steroids, rings. Simple lipids, simple glycerol with chains of fatty acids. Compound lipids, lipid with carbohydrate, lipid with protein, like that. And steroid, ring structures. Okay? Since they are ring structured, they won't react with NaOH. Fat, if you take fat, animal fat, put NaOH on it, it will become soap. That's how they make hari soap. Yeah. They take fats, put oil, put NaOH on it, it becomes what? It becomes soap. Base can't react with them because they are ring structures. Some common steroids are cholesterol. Cholesterol is good for our body. It makes a cell membrane. Cell membrane protects your cell against coronavirus. I mean, all the outside stuff. If you have lots of cholesterol in your body, your cell membrane is very strong. For a long time, cholesterol was demonized by doctors. But now they realize that they were wrong. Cholesterol makes everything, especially sexual development of a body, cholesterol. Okay, if human want to have a healthy life, they must have a good cholesterol inside their body. It can make progesterone, all hormones, cholesterol. So cholesterol, most common steroid. Okay, virtually every cell has it. Blood has it. Spinal column has it. Brain has it. Cholesterol is important for us. And number 2 point, which is from the textbook, don't like this point. I personally hate this point. It deposits in the arteries to elevate blood pressure, causing heart attack. What is that? If this is wrong, then why we came here? Because any person who died by a heart attack, when they check his arteries, the arteries were blocked by waxy material. When that vaccine material was tested, it was cholesterol. And everybody said cholesterol is the bad guy. Why it happened? I tell you. When you eat a lot of carbs, your blood has a lot of sugar in it that causes arterial damage. The arteries from inside are damaged. This is the job of cholesterol to repair your tissues, repair your cells. It's duty. Cholesterol reaches there and fills that gap, that damage which is done by high glycemic food. And when and if you keep on taking that high glycemic food, cholesterol will keep on fixing it. But in the process, it will also block your arteries. So how is cholesterol bad guy? I tell you, if there's a fire in a building and you go to see that building on a fire, the first thing you see is a fire brigade, fire brigade truck trying to remove that fire. In the same way, when people die with heart attack and they check them, they see cholesterol there. But cholesterol was not the reason of dying. It didn't produce fire. It came there to repair. So cholesterol is important for us. We all should have a lot of cholesterol in our body, but we should not have a lot of glucose in our blood. All right? Especially when you are, if you are a young person, your body can handle it. But as you cross the age of 30, your body cannot handle glucose. It can handle fats, but not glucose. So cholesterol is good. Large amount, not good. Well, they say I will believe it. So then other is cholic acid comes from cholesterol. If you don't have cholesterol, how the hell are you gonna digest your food? Because cholic acid is in the bile. What? Yeah. This is the important thing for you. So when you take anti-cholesterol medicine, your body stops the breakdown fatty acids. Your body actually is deprived of healthy nutrients. You get more fat, you get more hungry, you get more sick, and you eventually die. I was for a long time on statins. I quit them because I was seeing very negative effect of not having enough cholesterol. Then progesterone is for the development of all hormones, sexual hormones, they come from them. So these were the cholesterol, the complex lipids. Now fatty acids, all carboxylic acid with minimum 12 carbon to 20 carbon are fatty acids. Okay. If you hydrolyze oils and fats, they will give you alcohol and fatty acids. If you understand esters, this is a game for you. And some of them are essential for us. If we don't take them, we will die. They are called essential fatty acids. Some of them are unsaturated, double bond. Some are saturated, like that. Yeah. See, 17 carbon, 17 twos are is 34. So it is very highly unsaturated, linolenic. So it's also 17, but you can see that it's different than that. The hydrogen are different than that, and there are so many others as well. Okay, so to prevent deposition, if you want to make a healthy life, you need cholesterol. There are two cholesterol. They say good cholesterol, bad cholesterol, and whatever. But cholesterol is not bad. Okay? HDL will protect you, and LDL will kill you. But reproduction function and many other function depend on these fatty acids. If if this is less in your body, you will have fat loss. Okay, your skin requires fats to protect against the outer side issues. So these were some easy breezy lemon squeezy topics for you, and I want you to share them and learn them and show them. You always show me, and I feel very good about that. Oh, and the test is on ninth and 10th chapter. And if you are not easy sharing with me your email address on my WhatsApp number, you can also email to me or you can share it with me on WhatsApp. Both are easy for me, and I'm trying to work on that. And very soon we'll have an online test. We because testing is important for us. When we have testing, it we get more motivation to study. Without, and you'll agree with me on that. Without tests, studies are like not easy. So it's my request to you to prepare for the test. Share with me your email address, and very soon we'll have this test. Result will upload. I don't want that some student participate and others don't. I won't like it. I want everyone to participate, and we will have a result share on Facebook as well. Thank you so much. That was the fatty acids, lipids, and fats. Tomorrow we'll learn about enzymes and then vitamins to complete this chapter. So that's it from my side. Thank you so much. Goodbye.